Uh-huh.
So like these kinds of, where you have a dot and vectors and stuff, that's called a motion diagram.
Uh-huh.
And that's where you can see physically on your paper what the motion would look like. But position versus time graphs are when you take position. So when you hear position versus time, you know that it's, when you hear anything versus anything else, you know that one is going to be your y-axis, the other one is going to be your x-axis. It's always position versus time. So position would be your y-axis and time would be your x-axis. The first one is your y, the next one is your x.
Okay.
So if they say velocity versus time graph, this is how you draw velocity up here and time down there. Same thing with acceleration versus time.
Okay.
So this is what they want. They want you to draw a graph of position versus time. So this will be in 2 dimensions, right? Because the position changes over time.
Yeah.
So let's look at we'll just go through these ones because they're pretty simple.
Okay.
So a student walks to the bus stop, waits for the bus, then rides to campus. So he starts at 0, right? And you can just say that he starts at 0. And if he's walking, is he changing position with time very much?
Yeah.
Yeah, he could have a
Oh,
pretty
wow.
good speed. So you see how that works?
Yeah.
Each second that passes, he goes such and such amount of distance.
Uh-huh.
Right, that's kind of how that works. And then what happens when he stops?
He gets on a bus or waits for a bus.
Right, so he's waiting for the bus. So what's happening to his position as time goes on?
So it doesn't change. He
Right.
stays there.
So then you have a straight line. And then once the bus comes, then his position is going to change with time again. And it'll probably be a little bit faster than when he was walking.
Uh-huh. Okay.
From this graph, you can get your velocity versus time graph and your acceleration versus time graph.
We've done that.
So that makes sense. He's walking kind of slowly, he stops for a little while, and then he gets on a bus and drives. So what would the next one look like?
Okay, the next one is a student walks slowly to the bus stop, realizes he forgot his paper is due, and quickly walks home to get it. So he's going to start at 0,
Mm-hmm.
and then it says he slowly walks to the bus stop, so he will get to the bus stop.
So it'll kind of be like a pretty shallow slope here.
Yeah. And then it says that he forgot his homework, so he goes back. So time is going to keep going forward, but his
Mhm.
position is going to go down.
Yep. So this time he goes quickly. So he takes, here maybe he took a minute and a half to walk to the bus stop. But then over the next part, when he gets home, maybe he only takes 30 seconds. So he's going to jet back home. And you can see that he covered a lot more position. I mean, he covered the same amount of position here, but in just a lot less time.
Uh-huh.
That's how that
Okay.
works. So then the last one.
All right. So,
This one's kind of confusing. I have to read it again. So the quarterback drops back. Oh, okay. He drops back 10 yards from the line of scrimmage, then throws it past 20 yards to the tight end, who catches it and sprints 20 yards to the goal. Draw your graph for the football. Be careful about what the slopes of the line should be. So let's say our line of scrimmage is at 0.
okay.
So what does it mean that he drops back?
It goes backwards?
Mm-hmm.
So-
So start at 0, go backward.
Okay. So, because his position is getting negative, but the time is going forward.
Mm-hmm.
And then he throws a pass. So we're watching the football. So 20 yards to the tight end. So it's going to be,
So you can say this is negative 10 yards. We know that.
okay. And then so it's going to be 10 yards on position.
And that throw, how much time is that throw going to take?
They're pretty quick.
Yeah, so maybe this will have a really steep slope and gets to the tight end here.
And then he sprints 20 yards to the goal.
So eventually he'll get to 30 yards.
Uh-huh.
Here's 20.
And he's sprinting. He probably can't, I don't think he can run as fast as the ball through him, but he'll probably get there pretty quick.
So it'll probably be maybe even steeper than the quarterback was moving backwards. He'll probably be running pretty quick and he'll go something like that
Yeah.
to get to the goal.
Okay. That makes sense.
So then, let's take a look at just this one right here, and let's see if we can find the velocities. And let's see. All right. So if we wanted to take this graph and draw the velocity versus time graph, what would we do?
So you need to line up the graphs first, right?
Yeah. Yeah, so we'd have to draw another graph just kind of directly below it. Yep.
Okay, so velocity is the slope of the line, right?
Mm-hmm.
And so the slope is negative, and so his velocity is going to start out, well, either at 0 or a negative.
So if it were a 0 velocity, it would have to be a line like that, right?
Okay.
So right off the bat, it's negative, which
Okay.
kind of makes sense, is that quarterback's going to jump up and just start going backwards immediately. He's probably not accelerating to that. He just can kind of pick up and go that speed. So it will be negative. So it'll start here. And then what will the line look like?
It'd just be straight, right?
Yep. So that slope doesn't change at all.
Yeah.
It's just the same slope the whole time. So up until this point, he just has that slope right there. I'm dropping this microphone. Okay?
Okay. And then the next line is a really, really high slope, so it's going to be pretty positive.
Mm-hmm. So up till this point, that's not. Oh, so it'll be pretty high, maybe up here,
Uh-huh.
and then for the rest of the graph,
It won't be as high as that one, but it'll still be positive.
perfect. And I'll go to the end, and we could take this and find out the exact values since we have numbers and stuff, but we don't need to do that. It's just rise over run. So here you'd have -10 over 2, so it'd be -5 yards per second. So pretty straightforward. And then, just for the sake of kind of being complete here, this is yards per second. What would be, we won't draw it, but what would the acceleration graph look like?
Okay. So his acceleration from the first to the second is going to be really high because he went.
Yeah, in that one instant, but we're going to imagine that's just in an instant it changed. And so you're right, there is a huge acceleration there, but it happens in such a short time that we can't even show it on a position versus time graph.
Okay. So then, but for that has no acceleration. They're straight lines.
Mhm.
They're constant.
So yeah, that makes it really easy to draw acceleration versus time graph because it's just all 0. As long as you have linear motion like this, we know that except for these points where we can't determine acceleration at that point, because acceleration has to be a change in velocity over time. That you don't have any time here because it just happened. Then it's just going to be equal to 0.